Okay, 5.4 is all about various properties of logs and eventually how to solve more interesting log problems. We're going to start with the basic properties in this part and show how to use them. And then in part two, we'll introduce some other properties of logs. These are the fundamental properties here, the basic ones. Okay, and here are all the rules here, but we need to figure out what they equal rather than just state the rule. I believe these are on the first page in the section of the book, 5.4. So rather than just state them, let's kind of see why they equal what they equal. It'll help us to understand them better. So there is a property that log b of b equals something, and it's always the same. And what is it? Well, if you remember, we can convert back to exponent form. So the base here is b. The power here is out here. We don't know. The log returns the exponent, so that's a question mark. And the number is b. Well, the only way this can equal this is if b is to the first power. So there's our first property of logs. If the base and the number match, it's 1. Let's look at this one now. Same idea. I have a base. I don't know what the exponent is. I want to find out for this rule. But I know that the number is 1. Well, the only way that you can get a number equal to 1 by raising it to a power is if that's the 0 power there. So this is always true here. So here's our next property. And again, if I'm given any log problem, if I have the log of 1, it's 0. It doesn't matter about the base or anything else. This one's a little bit more interesting looking. So let's take a look at this one. The base is b. We don't know what the exponent is, but the number we're trying to get is b to the x. That's this argument here. Well, again, remembering back on that rule of where if the basis is the same, the exponents have to be the same, then that means this has to be x. So this is an interesting rule here. And the way to kind of use this rule is to think of log b and b cancel each other out. So if the base here and the base here is the same, then you're just going to get the exponent as the answer. So it's like they cancel each other out. Similar thing here. Here we're starting with the exponent form, so we're going to convert back to log form. So log base is b. Oops. Hold on a minute. Made that too big. Base is b. That's better. Okay, this is the exponent right here. So we don't know what the number is. I did it again. Making those b's too big. Log b to the x. Okay. So, what do we have here? Well, everything matches. This is log b to something. This is log b to x. So that means this has to equal x. So it's the same idea as here, except it's kind of the reverse. When you have a base raised to the log of the same base, and again, that I wrote that big, that b kind of big, I'm sorry, that's log b down there. Again, the log and the base cancel as long as they're the same. So it's just x. So here's your rules. And again, they're in the book on the first page of the section. So let's try them out real quick with just a couple simple problems just to see them in action here. So here's an easy one. Again, as long as the base and the number match, the answer is always 1. So let's look at another one here. How about natural log of 1? Well, natural log is still a log, it's just log base e. And again, anytime you have the log of 1, you always have 0. Doesn't matter what the base is, what the log is. If it's log of 1, it's 0. So there's an example there. How about this one? Okay. This is an example of this one. When the base and the base of the number match here, it's raised to an exponent, then think of the log and the bases canceling. So this is just going to be 5. So again, this is a base right here. It's 7 raised to a power. This is a base. This is the log of this base 7. So the bases cancel and the log goes away. Same idea here. Okay, so what would this equal? Well, again, remember, ln means base e, so that's e to the 99, if you think of it like that, but this is a base e, so these bases cancel here. So I could rewrite this as log e to the 99. That's the base of the log. That's a base being raised. If the bases match, they cancel. That's just 99. And that's an example of this rule right here. Okay, that's how they work. So let's do a couple of problems using these rules. So what you want to do on log problems a lot of times is try and isolate the log term and then see if you can figure it out at that point, or if you can do a conversion and then get to an answer that way. So we'll see how that works now. So let's look at this one first. Okay, this one, the log term's isolated, so we don't have to do that. But the problem here is, if that was ln 1/2, you just put 1/2 in, hit the ln key, and you can get the answer. But we're trying to figure out what the number would be to get an exponent of 1/2. We don't have a key to do that. So you look at that and you say, well, I got to do something else. So if you start looking at these rules here, we might want to go ahead and apply this one so I can get this number out of there. In other words, I'm trying to get rid of the ln. One way to do that, since that's ln, if I use a base e on both sides and rewrite it as e to the ln x equals e to the 1/2. Okay, now I'm using this rule. This has the same base in the log and the base itself, so it cancels, so I get the x where I want it. Now I can use the calculator. If I enter 1/2, then hit the e to the x key, I'm going to get a big number, and what I'm going to do is I'm just going to round it to 1.649, and I'll use that. Hopefully when you're doing a problem, it'll tell you what place to round to. If it doesn't say anything, you're free then to do what you want. So I'm going to do that. So There it is. Okay, that was an easy one. Let's look at a little more difficult example. This one we'll have to do a little more work. Okay, again, before we want to apply any rules or try and do anything, we want to isolate the log term. That means I need to get rid of that, and then I need to get rid of that. So I get just log. All right, so we're going to subtract 2 from both sides. Okay. So 3 minus 2 equals 1. Now I'm going to multiply both sides by 3, so that'll get rid of this 1/3 over here. And 3 times 1 is 3. Same problem here. If I had log 3, I could put in a 3, hit the log key, and I would get a number. I don't have that. I'm trying to get this x out of here, and it's stuck. So if I go up here and I take a look, I can use this rule again. Since the base is 10, I want to raise each power to the 10, or use 10 as the base. So what we're going to have is this. That'll be 10 cubed there. So again, I've got a base raised to a power. I've got a log, and the bases match, so these cancel. So that brings the x term out so I can deal with it. That's what we want. And then over here, 10 cubed, put in your calculator, or it's pretty easy. 10 times 10 is 100. 100 times 10 is 1,000, so we'll just put that. And now I can easily solve for x. Subtract 1. Divide both sides by 3. Okay. And I'll do one more example, and that should wrap it up for these rules. Let's look at this one here. Get to use a different rule on this one instead of this one all the time. Okay, and again, that's e raised to the 0.05x plus 1. That's the power on e. This time we have an exponent here, but if we could isolate that exponent term, then maybe we could use one of these other rules here. So let's try that. So first let me subtract this from both sides. Okay. Now we're going to divide both sides by 250. Now what we're going to do, rather than use this rule, I'm going to use this rule. Because I already have a base raised to a power, I'd like to get that power out of there. So if I use log of the same base, it'll do it. So what we want to do is this. Since that's base e, I want to take the natural log of both sides. Okay, so now we're using this rule. So since the base here and the base here, this is really log e, match, they cancel out. And that gets the x term out where we can work with it. And then again, if I enter 4, hit the ln key on my calculator, I I'm going to get something like, and again, it's an approximation. I'm going to round to 3 places. So I should have squigglies here, but let's just do this. We're going to say that's accurate to 3 places. Now I'm going to subtract 1 from both sides. And then the last thing I'll do is divide both sides by 0.05. And again, this is going back to watching your work. When I divide a number by a number that's smaller than 1, I should get a bigger number. So I'm expecting, that's pretty small, so I'm expecting something much bigger than 0.3. And as it turns out, it is 7.72. Okay, so those are the properties. This is an example on using the properties. And then we'll look at some more interesting properties for working with logs next time.